My dear students, Assalamu alaikum. So today we will start the second lecture of nomenclature. So we will start our nomenclature from the alkenes. So the nomenclature of alkenes is similar to alkanes. In this case, we have a one or more double bonds in the long chain, so we have called it alkenes. So in this case, we have to select the longest chain which contains the double bond. The difference from alkanes is that in alkanes, we will start the longest chain, we select the longest chain which contain any substituent. But in this case, alkenes, we will select the longest chain which contains a double bond. So this is called alkenes. The simplest alkene is ethene, because the compound containing no double bond is called ethane. So with one double bond, this compound is called ethene, and with one double bond and 3 carbon chain, it is called a propene. And there no need to give the number of the double bond, because in these two cases there are no option and double bond cannot be some other side. But in case of butene, when we have 4 carbons, you must have to mention the position of the double bond. For example, in this case, we will start from here. It will give you 1, 2, 3, 4. The double bond between 2 and 3. And if we start from here, it will also give the same number. So you have to give the least number to the double bond. So in this case, the double bond is starting from the 2 carbons, so it will be 2-butene. Similarly, now if we have a longest chain and we have a substituent, for example, in this case, this one is the longest chain and this one is the substituent, which is a methyl group. Now we have to start numbering, but must consider that we have to give the numbering least possible number to the double bond, not to the substituent. For example, if we start numbering from here 1, 2, the substituent will be on 2 position, but then in this case the double bond will be on 3 position. So we'll start from numbering from here 1, 2, 3, 4, 5, so that the double bond must be at the least position. So it will be 2-pentene. The compound parent name is 2-pentene, and this methyl group at 4th position is a substituent. So the total name of this compound, full name, will be 4-methyl-2-pentene. Similarly, in this case, you can see that the longest chain will be like this one, 1, 2, 3, 4, 5, and you have to take care that longest chain must contain the double bond. And we have 2 substituents. This is methyl group and this is chloro group. Now we have to start numbering from that side, which give the least possible number to the double bond, not to the substituent. So if we start numbering from here 1, 2, then the substituent chloro will be at least position, but double bond will be at 3. So we start numbering from here 1, 2, 3, 4, 5, so that to give the least possible number to double bond, not to the substituent. So the parent name of this compound will be 2-pentene. And now we have 2 substituents, one at 3 position, one at 4 position. We have to see which one is alphabetically first. So one we have methyl and we have chloro. Because chloro is first, so it will be written first. It will be 4 chloro, 3 methyl, 2-pentene. So it is the case. You can see a lot of examples of these alkenes. Now we move on to the next topic, that if we alkenes are used as a substituent. For example, you can see this case here. We have a cyclohexane ring and the longest chain contains 1, 2, 3, 4, 5 carbons. So in this case, this chain is a substituent and this will be a parent name. So parent name will be a cyclohexane, and this chain contains, which is an alkane. As the alkane chain is converted into alkyl, so the compound chain containing a double bond, this chain will be converted into an alkenyl. So any chain, if a chain contains a double bond and chain is a substituent, then the name of that chain will be alkenyl. If you have a double bond, it will be ethenyl. If you have a 3 carbon chain, it will be 2-propenyl, and so on. In this case, the chain is called the pentenyl. So the name of this compound is pentenyl cyclohexane. I told you in case of the cyclohexane that if the chain number of carbons is more than the ring, then that chain will be used as a parent name. But if the ring carbon is more as compared with the chain, then ring carbon will be used as a substituent. As a parent name, it is a cyclohexane, and because it is 5-membered ring, so it is considered as a substituent. So the name of this compound will be pentenyl cyclohexane. Now you have to give the number of double bond. So must consider this one, that in case of substituents, the numbering starts from here. The carbon which is attached to the ring, that will be the number 1 carbon. Always, if you have double bond present here, if you have any other substituent attached to this one, always in a substituent chain, the numbering starts from the carbon which is attached to the ring. So this will be the number 1 carbon. So in this case, the double bond comes on 4. So the name of this compound will be 4-pentenyl cyclohexane. So another example, we can take some more examples. We have a cyclopropane ring and we have a 3-carbon chain. Okay, so because cyclopropane ring contains 4 carbons, which is more than the chain, so the parent name will be cyclobutane. And because this is a substituent and substituent contains double bond, the propane will be considered as propenyl. Now we have to give the position of the double bond. Always the number 1 carbon will be the carbon which is attached to the ring. So it will be 1, 2, 3, 2 propenyl cyclobutane. Now I'll take another example. If our cyclobutane ring, which contains 4 carbons, is attached with a chain which contains more than 4 carbons, like this one. In this case we have 1, 2, 3, 4, 5 carbon straight chain. So now in this case, because this chain is more carbons, so this will be considered as a parent name and cyclobutane will be considered as a substituent. So the parent name of this compound, now forget this one, so the compound name will be 2-pentene because this one is the parent name. So it is a 2-pentene, and on 2-pentene at 5th position cyclobutane ring is present. So it is 5-cyclobutyl 2-pentene. Okay, we'll take another case. If we have ethynyl and propionyl, these are some special alkene groups. The ethynyl is named as vinyl. This is the common name, vinyl group and allyl group. This carbon chain, 2 carbon chain compounds with double bond, it is called vinyl. Is attached to some other substituent, then this is called a vinyl. And if this compound we have 3-membered ring, a 3-membered chain with this carbon is attached to some other ring or substituent, this is called allyl. These common names are very special. Why? Because these are still used in nomenclature, IUPAC nomenclature. For example, in this case you can see that this vinyl group is attached with chlorine. The name of this compound is vinyl chloride. This can be used in IUPAC nomenclature still, this vinyl name. And this allyl name can also be used still. So if you have allyl group and someone is attached, some bromine is attached, it is called allyl bromide. So these two names are very special in alkenes, vinyl and allyl. Vinyl is a ethynyl group and allyl is a 2-propenyl group. Now move on to the further few examples. Cycloalkenes. Cyclic rings which contains double bond. So the general name for that compound is cycloalkenes. For example, you have this 5-membered ring with a double bond. It is called cyclopentene. If we have 4-membered ring double bond, it is called cyclobutene. If we have a 3-membered ring with a single double bond, it is called cyclopropene. There is no need to give the numbering of the double bond. Why? Because always double bond will be between the 1 and 2 carbons. So if we have any substituent here, for example, we have chloro group here. So always the number 1 and 2 carbons will be this double bond. Start numbering from that side, which give the least possible number to this substituent. For example, if we move from this side 1, 2, 3, 4, 5, and if we move from this side, it will be 1, 2, 3, 4. So this will be the actual numbering, and the compound name will be 4-chlorocyclopentene. No need to mention the position of the double bond because double bond will always be the between first and second carbon. If you have more than 2 double bonds, then you have to mention the position of the double bond. It will be 1, 2, 3, 4, 1, 3, cyclo, butadiene. And you have your 3 double bond, it will be cyclotriene and so on. Like this one. If we have a common chain, open chain, and if we have double bonds, then these are called butadienes, means it will be 1,3 butadienes. Or you can write buta 1,3-diene. This number can be written in the front of the name or in between the name. It can be written as buta 1,3-diene and so on. So this is all about the alkenes. So similar method is used for the alkynes. If you have alkynes, the general name will be the butane, and numbering will be 1, 2. Similarly, you have to select the longest chain, and you have to give numbering from that side, which give the least possible number to the triple bond. It will be 2 butane. It will be like this one, 1, 2, 3. It will be 3, 4, 5, 6 hexyne, and so on. If you have some other substituents, you have to select the longest chain which contains the triple bond. So if you start from here, 1, 2, 3, 4, 5. But if you move on this side, it will be 5, 6. So this will be the substituent. So the parent name of this compound is 2-hexyne. And at 4th position we have substituent. So we'll write here 4-methyl-2-hexyne. Okay. Next one. If we have any other substituent with the triple bond, like this one, now in this case, we have to take care that we have to give the least possible number to the triple bond. If we start from here, it will be 1, 2, 3, 4. If we start from here, 1, 2, 3, 4. Now, because from both sides we can give 4 number to the triple bond, now we take care the substituents. If we start from here, it will be 4th position at triple bond, but the bromo will be at 6th position. But if we start from here, 1, 2, 3, 4, 5, 6, 7, 8. So there is no change in the position of triple bond, but the substituents get the least position. So you have to take care that give the least possible number to triple bond, and if on from the both sides triple bond get the same number, then we have to start from the side which give the least possible number to the substituents. So the parent name is 4-octene. You have to write the parent name first and then write the substituents. These are the 2 substituents, chloro and bromo. Write them alphabetically. So bromo is first, so it will be 3-bromo, 2-chloro, 4-octene. Now, if the triple bond is used as a substituent, then the alkyne's name will be alkynyls. Alkynyls as a substituent if triple bond is used. For example, if you have this cyclohexane ring and if you have this group. Now this group, if it has a single bond, it will be called as ethyl. If it has a double bond, it is called ethenyl. But because here it has a triple bond as a substituent, so the name of this compound will be ethenyl. Ethenyl cyclohexane. Ethenyl cyclohexane. And if we have 2 substituents here, it will be 1,2 diethynyl cyclohexane. 1,2 diethynyl cyclohexane. Similarly, if you have a cyclopropane ring, and with the cyclopropane ring you have this group. So now you can see this cyclopropane ring is here, and here you have 1, 2, 3, 3 carbons, and these 3 carbons will be considered as substituent. So the parent name is cyclopropane, and on cyclopropane substituent is attached, and its name is propynyl. So how we can give numbering to the substituent? Always numbering starts from the carbon which is attached to the ring. So it will be 1, 2, 3, 2 propynyl cyclopropane. Now we see the case if both the alkenes and alkynes are present together. For example, this one, both alkenes and alkynes. For example, if you have this compound, so in this case you can see that if we start numbering from here 1, 2, 3, 4, 5, 6, the triple bond will be in one position and double bond will be on the third position. So in this case you have to give the numbering to any triple or double bond. So because the triple bond gets the numbering from here, if you start numbering from 1 here, but if you start numbering from here, it will get the highest number. So we start here 1, 2, 3, 4, 5, 6. So the parent name will be 3-hexene, E will be removed, hexene 1-ine. So general name of the compounds which contain both alkene and alkyne, the general name is alkene-ine. Alkene-ine. You have to give the number of double bond before the start of the name and give the number of the triple bond before the start of the ine. So it will be 3-hexene 1-ine. But if you have a condition, both double bond and triple bond gets the least possible number, then what you have to do? You have to give the least possible number to the double bond. If both the double and triple bond gets the least position, then start numbering from the double bond and give the name. So it will be 1-hexene 5-ine. Give the highest number to the triple bond but the least number to the double bond. But if you have condition anyone can get the least number, then start numbering from that side which give the least position to any double or triple bond. For example, if you have this compound, so if you start from here, it will give the second position, but if you start from here, double bond will give the first number. So start from that side which give the least possible number to any double or triple bond. So it will be 1-hexene 4-ine. So if the compound contains both double and triple bond, the name will be alkene-ine. The number before the alkene shows the position of the double bond. The number before the ine shows the position of the triple bond. If you can give the least possible number to any double or triple bond, start from that side to give the least possible position to any double or triple bond. But if you have a position in a situation in which both the double and triple bond can get the least possible number, then must give the least number to the double bond and the highest number to the triple bond, in this case 1-hexene 4-ine. Now we move on to the nomenclature of alkyl halides. The general name for alkyl halides is haloalkanes. For example, if you have a methyl group with chlorine, the name of that compound will be chloromethane. So this name is different from the general name. General name was methyl chloride, but the IUPAC general name, this one is IUPAC general name. This one is haloalkanes. So you have to write the halogen name first with O and then write the name of the alkanes, haloalkanes, chloromethanes, then bromomethane, Cyclopropane. Now you have to mention the position of the fluorine group, because in these two cases there are no second option. So here we have option fluorine can be here, can be here. So remember, start numbering from that side to give the least possible number to the halogen group. So it will be 1, 2, it will be 2 fluoropropane. Another example, if we have a long chain and we have a halogen group is attached and a methyl group is attached on both sides. So keep remember that the halogens are respected as the alkyl groups. It means there is no preference between the halogens and the methyl groups. Halogens and methyl groups, they are treated both in the same manner. If you start numbering, you have to give numbering to any one of these. If you can give the least possible number to the alkyl groups, give the least possible number to alkyl groups, not to the halogens. It means the halogens are not a special group. Halogens are treated as like alkanes. So if you start numbering from this side, the halogen chlorine will be get the third 3 number. So we'll start from here 1, 2, 3, 4, 5, so that we will give the least possible number to any of these halogen or the methyl substituents. So the name of this compound will be pentane. Now write these two substituents alphabetically. There is no preference given to any of these substituents. So this one is chloro, this one is methyl. So first alphabetically we'll write chloro. It will be 3 chloro and 2 methyl pentane. So always remember not to give a special preference to these halogens. Halogens and methyl, ethyl, all alkyl groups, they are treated as such in the same manner. So for example, we have this compound. So now we have a cyclopentyl group. It is a cyclopentane. This cyclopentane is the parent name. On this cyclopentane, we have two substituents attached, iodine and ethyl group. So there is no preferences to anyone. Both these groups are normal groups. So we can give the number one position to any of these groups. So now we'll decide on the basis of alphabetically. So alphabetically, this starts with I, this starts with E. So start numbering from here. So to give the first number to the group which is alphabetically first. So the name of this compound will be 1-ethyl, 2-iodo-cyclopentane. There will be no hyphen. There will be no space between two words. Similarly, we have this group. So the parent name will be cyclohexane. We have three groups: methyl, chloro, bromo, which will be at least position number one, the one which is alphabetically first. So it is bromo, it is chloro, it will be 1, it will be 2, 3, 4. Start numbering from that group which is alphabetically first and write in the alphabetical manner. So it will be 1 bromo, 3 chloro, 4 methyl cyclohexane. Similarly, if we have this compound, now you can check what is this. This is a longest chain, 1, 2, 3, 4 carbon chain. Sorry, 3 carbon chain, 1, 2, 3, on which iodine is attached. So give numbering to any one of these. So numbering, you can give this methyl group, the substituent, this iodine, and this is the longest chain. So it will be a propane. So start numbering from here, which give the least possible number, because if you start numbering from here, you will be on 2 position. So start numbering from here, 1, 2, 3. It will be 1 iodo, 2 methyl propane. will give you one more example. This one. So this is a cyclohexane. On this cyclohexane, two substituents are attached, fluoro and ethyl. Which will be first? This is alphabetically first. So ethyl group will be number 1 and fluoro will be number 2. It will be 1 ethyl and 2 fluoro. Cyclohexane. And what will be the name of this compound? Now you can see that this is the parent name, which is cyclohexane. And this one, the iodine is present on the substituent. Now you have to decide the name of this substituent. So first, remove this one separately and write the name of this one. If we have separately this compound, this will be iodoethane. This will be iodoethane because we have two carbons on which it is attached. So because ethane, and when substituent is attached, it is called ethyl. So now iodoethane becomes iodoethyl, and it will be written in bracket iodoethyl. So it is iodoethyl cyclohexane. But we must have to mention the position of the iodine because iodine can be on this side. So, which will be the number 1 carbon? In substituents, always number 1 carbon with that carbon which is attached to the ring. So it will be 1 iodoethyl cyclohexane. Remember that if you have the substituent name which consists of any numbers, which consists of more than 2 words, then you have to write that substituent name in a bracket. If you have a substituent name, single name, ethyl, methyl, propyl, cyclohexane, it's okay. But if you have substituent name which contains one number at least, or which contains more than 2 branches or 2 names, then you have to write this substituent name in the bracket. It means that this cyclohexane is a ring on which iodoethane is present, and iodoethane, the iodine is present on the first carbon of this ethane, not cyclohexane. So it will be the end of this second lecture. Inshallah, next time we'll discuss the nomenclature of ethers.